Okay, now I'm going to start about the pipeline. So pipelining is the one of the important feature of 8086 microprocessor. In 8085 microprocessor, pipelining concept was not there, but it was introduced in the 8086 microprocessor system. So what is pipelining? Fetching the next instruction while the recent instruction executes is known as pipeline. So what is the meaning of that? What is the instruction? When I'm giving some command to the 8086 microprocessor, in that time these commands are called the instructions. So different instructions we have to give. We need to give into the 8086 microprocessor as per my work or as per my need. Okay. So suppose in this example, this is the instructions queue. Okay. So I'm giving suppose instruction 1, 2, 3, 4, 5, 6. Suppose instructions I am giving to the 8086 microprocessor. So this six instruction will go through some fetch. First, the instruction will fetching. After that, it will be decode. That means it need to understand by the microprocessor. So it is called decode. After that, what actually I want to do with the instruction, this will be this work will be execute. So this is the three steps will be there. Fetching the instruction, decode the instruction. That means microprocessor uh, try to try to understand the instruction. It is called decode. After that, it will do the work as per the instruction. It is called execute. So three stages are there. Fetching. Fetching means first it will be fetch into the 8086 microprocessor. After that, it will be decode. After it will execute. So in previous microprocessor before 8086, when we give an instruction to the microprocessor, all these three things will be do first. After that, next instruction will be come into the picture. That means one instruction will be go through fetch, decode, execute. After that, next instruction will be go fetch, decode, execute. Like, but in 8086 microprocessor, it will not happen. First, one instruction will fetch. Next, when this instruction is going to decode, in that time another instruction will going to fetch. When the first instruction will going to execute, in that time the second instruction it will be going to decode. And another third instruction will be going to fetch like that. So I am going to describe it with the help of this diagram. F means fetch, D means decode, E means execute. So this is the clock cycle. Clock 1, clock cycle 1, clock cycle 2, clock cycle 3, clock cycle 4, and clock cycle 5. Suppose I am giving some instruction. I1. I1 means instruction 1. I2 means instruction 2. I3 means instruction 3. Like that, I am giving, suppose I am giving 9 instructions into the microprocessor. First, instruction 1 will be going to, in first clock cycle, instruction, in the first clock cycle, instruction 1 will be going to fetch. Second clock cycle, instruction 2 will be going to fetch, and instruction 1 will be going for decode. In the third clock cycle, third clock cycle, in the third clock cycle, instruction 3 will be come into the fetch, instruction 2 will be decode, and instruction 1 will be execute. Same thing in fourth clock cycle, instruction 4 will be going to fetch, instruction 3 will be decode, and instruction 2 will be execute. Like that, fifth clock cycle, instruction 5 will be fetch, 4 will be decode, 3 will be execute. So parallelly, all instruction will going to process during this clock cycles. So what is the main advantage of this pipelining concept? That means it will be take less time, first of all. So when one instruction is decode, in that time, already the next instruction will going to fetch. So multi-purpose work is happening, you can tell. Same thing when one instruction is execute, in that time, another instruction is into the decode position, and another instruction is in fetching position. So all work is going to parallelly we can able to do. So this concept is called pipelining. So 8086 microprocessor, it is pipelining concept is very much important. And in 8085, the previous version of microprocessor before 8086, it was 8085. This phenomena was not there, or you can tell that this features not available. So during the pipelining process, the execution time will be very much less, and very less time is needed to execute one work in the 8086 microprocessor. So this is the thing. On non-pipeline processor, 9 clock cycles are required for individual fetch, decode, and execution for 3 instructions. On pipeline processor, fetch, decode, and execute operations are performed in parallel. Only 5 cycles are required to execute 3 instructions. What I told you already. That means less time is needed, simply. One instruction required 3 cycles to complete. Additional instructions complete at rate of 1 per cycle. During 5 clock cycle, 5 I3 instruction executing, I4 is decoding, I5 instruction fetched. What I already discussed in the previous slide. If 1000 instructions is required, 300 clock cycles on non-pipeline processor required. Suppose 1000 instructions are there. If it is a 300 clock cycles is needed for non-pipeline processor, same thing, it will be only 1002 clock cycle is needed for pipeline processor. So in 8086 platforms, fetch, decode, execute instruction in parallel. What I told you already, this thing. So these are the features of 8086 microprocessor. This is the important feature of 8086 microprocessor. So in my next class, I will discuss about some other features of 8086 microprocessor. Thank you.